Jackson Systems is your controls expert in the HVAC industry. With our top-notch technical support and customer service, we make life easier for you, the HVAC contractor. We offer free trainings on any product sold here at Jackson Systems, along with our filter fetch program, free thermostat and printing, home and business automation with connected sensors, cameras, and even smart stats from Nest, Ecobee, Honeywell, White Rogers, Google, and more. Visit us at jacksonsystems.com to see the products that continue to win industry acclaim among contractors worldwide. Jackson Systems, controls done right.
Guys that have listened to us at HVAC Shop Talk for a while have heard us talk about getting a free Zoom Lock toolkit with the purchase of a certain amount of Zoom Lock flame-free refrigerant fittings. Well, that's true. If you purchase 350 of the flame-free Zoom Lock fittings, you can get a free tool with that. But what you might not know is if you go to the Zoom Lock Roadshow and make that purchase, you can get it for 300 Zoom Lock flame-free refrigerant fittings. That's quite a deal, guys. Go to zoomlockroadshow.com and find out where that truck's at so you can flag it down and get your Zoom Lock tool today. You're listening to HVAC Shop Talk, a proud member of the Blue Collar Roots Network. For more information about HVAC Shop Talk or one of the many other podcasts on the network, visit bluecollarroots.com/podcast. Welcome back to HVAC Shop Talk. I am Zack sitting alongside Ralph Wolf. We are going to be welcoming back one of our favorite guests, Mr. John Pastorello, here in a little bit. But first, let's touch base with Ralph Wolf over there in Canton, Georgia, with an update on what's going on in Georgia.
It is windy and cold here, Zach. Can you believe it?
I believe it. I actually saw a Facebook post earlier today with our good buddy Brian Orr playing in the snow in Georgia.
I know. He's only an hour and a half from me.
Wow. So he's coming back from his family vacation. Our buddy Chuck sent us a picture of a lot of snow up where he's at.
I'm glad that stuff's up there, not down here, though.
Me too. I don't really like it. It's probably 50 degrees outside here, so it's not cold at all.
I bet one thing, when Brian gets back to Florida, I bet he's going to enjoy it down there. He loves it up here, though.
I like it up here. I like it when it's cooler. Not as much cooler up here, but I kind of like being up in the mountains every now and then. I like the cool temperatures.
Yeah, he said he'd trade anything to live up in the mountains.
Really? Wow.
I don't know what it is.
I don't know either, Ralph, but since we're interviewing John Pastorello from Refrigeration Technologies today, we were going to talk about the additives because we're going to talk about additives in the podcast. Let's talk about the ones we've actually used in our lifetime. So I'm going to let you start. What is an additive in the refrigeration system that you've used?
I always tried to stay away from additives because I always thought if the manufacturer wanted it there, they would have put it there. But that being said, I have used Subco 88 and I have used AC Renew because I have some videos of AC Renew.
But they made you use AC Renew, right?
I wouldn't have ever used it had they would have not said, hey, you have to try this before we give you a new TXV.
Oh, yeah, those darn TXV guys, right?
Yeah. But, you know, instead of using AC Renew on one, it was an ADP coil, 13-seer train. I took the TXV out and put a piston in it. I got rid of that problem.
That's really good because pistons haven't had much problem at all. I've seen one piston myself and one piston online, and that's about it as far as the Copeland rust inhibitor issue on pistons.
I never saw any issues with it at all with the pistons. I mean, I've seen pistons put in backwards and pistons not installed or units with the wrong piston size in them. But other than that, I've seen dirt and stuff, but none of the rust inhibitor.
I think the reason why I saw it down here is because the pistons on heat pumps on the heating side are often smaller because I guess they're building up head pressure on the inside to put the heating into the house. So That's what happened in my case.
Oh, so you saw them on the outside?
Yeah, it was an outside unit. It was a Bryant unit that I installed in 2014. I took the piston out. There was some junk. Literally, you could see the junk in it. I just cleaned it out. I actually soaked it in alcohol, too. I just left it out there and sat it out there for a while and then kind of cleaned it out with one of those little deals you bring the pistons out with, little wire pieces that you pull pistons out with.
Oh, yeah. Yep.
So I use that to clean it out, and it seemed to do an all right job.
I always use the thermostat wire.
Yeah, I've used a thermostat wire. I've actually used a screw. I'll take a screw and just kind of poke it in the end where there's a little bit of tension on it and pull it out, too, without opening it up too much.
Normally, when it's in the cabinet, I can't get it out because it's got like oil residue in there, and the oil's kind of got it locked in place. I normally take the back of my hand, I make a fist, and tap on the coil. It's like it walks out of there.
That's what I did to all the Goodman air handlers when the pistons were stuck in them.
Yeah,
Tap,
yeah.
tap, tap, tap. You know, it's really like the Arthur Fonzarelli of HVAC.
Mhm.
You hit the thing, and then the jukebox plays your song.
There you go. Now, let me ask you a question. When you take the piston out of the outdoor unit on the heat pump, do you A, recover the refrigerant, or do you B, pump the unit down in heat and put all of the refrigerant in the indoor coil?
Well, I'm actually going to tell you that in this case, it was C, because the piston is in the service valve on this unit. I pumped it down just like you would in air conditioning.
Oh, okay. Okay. So you was working on ICP or a carrier?
Yeah, it was the Bryant unit. The piston is actually located in the service valve. Those of you who know a lot about carrier ICP, all your heating pistons are out there, which is kind of nice. So I just undid the service valve, took the piston out, cleaned it up, and put it back, and it was much better. I wouldn't say it was perfect, but it was much better.
Yeah, when you talked about the heat pump and the piston, for whatever reason, I was just picturing a Goodman in my head.
I know. I did a lot of Goodmans too, so I pictured them too, which would have been either pumping it down into the indoor coil or recovering all the gas.
But now you did a lot of Amanas, though, right?
Yeah, sure.
So the Amanas had a TXV in them?
They had a lot of TXVs in them, but just like the Goodmans in the lower SEER level, they had pistons out there, and the pistons were on the inside of the unit. You know, you had your liquid line run inside. It would turn up, and then would go into a piston and then a distributor. I'll tell you something, because you said it's Subco 88. I use Subco 88 too, but I'll tell you something. I'm not going to give away what happens in the podcast, but I was really surprised to learn what it's made out of.
You know what? I knew what it was made out of, and I can't remember exactly who told me the makeup of it. It might have been John, actually, that said it.
Well, I was really surprised. The smell that I loathe so much about Subco 88, I guess, has to do with that key component.
I guess so, but I know a lot of guys that use it on every install.
I used to use it quite a bit for the reversing valves, but John's going to chastise us on that, saying that we should never use this stuff.
I know. I put some of it in a unit with the TXV debacle that we always talk about. I used some instead of using AC Renew.
How'd it turn out?
I guess it worked okay.
Oh, you haven't been back?
No. I changed the TXV first, and then I added the Subco 88 to prevent it from happening again. The reason I started using Subco 88 was because a buddy of mine who worked on a lot of carrier package units, he was putting it in the package units and never had a problem with the TXV stuff.
That's an interesting thing. I got turned on to Subco 88 because of the reversing valve issues back before 2010.
Oh, yeah.
And it seemed to be okay sometimes, I guess. Sometimes I had to change valves, which is horrible, but sometimes it worked.
It just is what it is. We had to do sometimes what we had to do. Sometimes it's not what manufacturers say we need to do.
Let's move on to leak sealants. Now, I know you've used leak sealants before.
Oh, I've proved it because I put in videos.
That's right. So which ones have you used?
I have used the stuff in the can that I hate so much long time ago. I've used it a couple of times, actually. Since I figured out what it actually does when it's out of the system, I always wondered what it did when it was inside the system. So I stopped using it. So now, if I was to give somebody some advice, because now I'm not in the field any longer, so when somebody comes in the store and they're looking for stop leak and never use any of it, I can point them in the direction that I would use.
Which is?
The oil-based stuff.
Which is one particular brand.
Other brands make them. The oil-based stuff made by RectorSeal.
Right, so you guys do carry that stuff.
Oh, yeah. Yeah, we don't carry the one with Magic Frost. But James from RectorSeal is going to be at our store in December. So before he shows up, I may get some ordered. So at least it's there. If you're listening, James, I'll make sure we get some.
All right, here's what we're going to do with James. Since he's going to be at the store, you're going to be at the store. There's a conference room at the store. I'm going to meet you at the store. I'm going to bring the recording equipment. We'll podcast right at your store.
Hey, that's going to be great.
I'm going to try to do that for real. I'm going to make the declaration right now. I'm going to be there. Just make sure it's not laundry day or something like that, and I'll be there.
Yeah, it's going to be fun.
This is going to be a great time. We're going to have a great time. Y'all are going to have food. Y'all are going to order some kind of Mexican food. It'll be good. I have an enchilada.
Now, you ever been to a distributor meeting with a bunch of dealers? they always have a menu that you go by because somebody somewhere has picked the 3 dishes that you get to eat. You can't order off the menu.
4.
They make them in advance. To me, it's meals that I would never, ever order. You know, I'm like, who picks this stuff?
You want cow or bird?
Exactly.
No, I've been to a meeting. They did that. They said, you want this one or this one? And I'm like, I guess I want that one. I don't know.
I'm like, man, most of us are real guys. Everybody's a real guy in the field, whether you're in the supply house end or you're sitting behind a computer doing podcasts. We're all real technicians because most of us have been in the field for a very long time and have gotten smart and got out of it before something happened to us.
Well, that's right. We're all real guys out there. None of us are fake guys or we're not, invisible guys. We're all real guys.
We're real guys. And we didn't get to this point in our careers by not knowing what we were doing.
And you know what? I know one more guy who knows exactly what he's doing. You know who that is?
John Pastorello.
That's right. John Pastorello from Refrigeration Technologies. We're going to have a 2-part series with him. We're going to talk about the POE problem and some additives, and you won't want to miss either one of them.
Wait. I don't you go nowhere. I don't want to go nowhere yet. Before John comes along, I do want to say this. I really, really enjoy when John comes on. We talk about some stuff on the podcast, but then we talk about other stuff later on that you guys don't get to hear. He's really a great guy. We're going to bring him on more because he is a very intelligent guy and he knows about a lot of this stuff that we don't even think about.
He knows a ton of information and really surprised me personally with some of the stuff that he said. So that being said, let's get into part 1 with John Pastorello.
Roll it.
Ralph, what makes EWC's smart bypass damper so innovative?
EWC Smart Bypass Damper automatically measures, maintains, and monitors operating static pressure of any zone system.
Don't they all do that now?
Now, with EWC's curved blade design, it will maintain true static pressure in all modes of operation. It also comes with a 5-year parts warranty and is the only bypass damper that is ACA compliant.
Visit EWCcontrols.com for more information. There's a lot of tools out there used for flaring, but Yellow Jacket has come out with a new flaring tool that goes above and beyond the competition. It's either an electric or a manual flare. You can use your drill to flare it out or just flare it by hand. Each one of the flare holes has been tested 1,000 times, and the eccentric cone produces the best flares in the business. So before you pick up your next flaring tool, try out Yellow Jacket. You might like the versatility and the quality that comes with the Yellow Jacket name. Find out more about the electric, manual, lightweight flaring tool at yellowjacket.com. We have John Pastorello back from Refrigeration Technologies. And last time he was on the podcast, he mentioned the POE problem. And we didn't go into it because we wanted to save an entire podcast for that particular issue, plus whatever else we get to. You know how we are. We're going to get to a few other things that we haven't mentioned initially. So I want to welcome John back. I want to welcome Ralph here. And John, why don't you give us a little bit of background on what you call the POE problem?
Something good to say about POE oils today, as opposed to about 10 years ago. 10 years ago, a company in Europe developed a new additive for POE oils that blocked the reaction of moisture and the POE oil. The POE oil you buy today can tolerate much more moisture contamination than the POE oils about 10 years ago. That doesn't mean you can leave the cap off. You still have to be cognizant that it does still absorb moisture, and the less moisture it absorbs, the better that additive is going to work for you. But the POE situation goes back to the 90s, really, when all these fractional horsepower refrigeration compressors were being charged with POE oil, and then they were adding extra corrosion inhibitor. What was happening was that the inhibitor is a solid at room temperature and is dissolved into the oil. Too much solids will eventually fall out of solution. And where it's going to fall out is at the coldest spot in the refrigeration system. And in this case, cap tubes were plugging. The manufacturers didn't want to take responsibility, so they said, well, The reason your cap tubes are plugging is because you're not keeping the condensers clean and it's cooking the POE oil. That's why you're getting plugged cap tubes. Well, POE oil can handle 400 degrees of heat, no problem, without breaking down. And even a small little condenser that's lost its condenser fan motor, that's not going to get up to 400 degrees. It's barely going to get to 300 degrees. That's how they kind of skirted around any warranty issues. And of course, the guys had to go back and replace the cap tubes and dryers 3 or 4 times before they could finally clean out the system. The POE problem that has recently surfaced is possibly due to the fact that they again added too much corrosion inhibitor. And of course, when you do that, it precipitates out and it's going to form blockage at the coldest spot, which is the outlet of the TXV. And you can clean it, stick it back in, and then more solids are going to fall out and you're going to have this continuing problem. I tend to think that they actually did not put in too much corrosion inhibitor. With these corrosion inhibitors, they're very, very expensive chemicals. The manufacturer of this particular corrosion inhibitor keeps jacking the prices up because they basically own the market. I think that whoever formulated the oil for the compressor manufacturer went to China or India and bought a knockoff corrosion inhibitor and substitute that in so they could save some money. With products coming from India or China, quality, of course, is suspect, and you don't know what the real chemical and impurity level is of those chemicals. And I think it's basically caused by foreign substituted corrosion inhibitor. The cure for that was pretty simple. All you needed to do was dilute back the oil so it could redissolve all the excess solids. A typical contractor going into a wholesaler would need to buy raw POE oil. That is POE oil that was void of any inhibitors. Of course, you can't do that. POE oil you're going to buy at the supply house is already going to have a complete inhibitor package in there, complete additive package. There were other oils packaged in cans or bottles that could possibly have worked, basically dilute that oil back down to where it would redissolve the solids. I think they rolled the dice with those off-the-shelf additives and said, here, try this. It either works or it doesn't. I guess there was about a 50-50 chance that it did work for you. It's not that there was anything in those additives that worked a miracle. It was just the fact that they were able to dilute it back and redissolve all the excess solids. Analogy I like to use is, if you make your iced tea too sweet, you take some unsweetened iced tea, add it back into your iced tea until you get it back to the taste you like. That's my take on it, but definitely it's the corrosion inhibitor because it's the only solid additive that's actually put in those POE oils when they come from the formulator. And by formulator, I mean the POE manufacturers. They will manufacture the oil to the compressor manufacturer's specifications. And that compressor manufacturer, of course, puts the oil through a lot of life testing to make sure that the lubricant holds up over time.
The story I got, John, about what really happened with the rust inhibitor was that they had changed the rust inhibitor for whatever reason, and it reacted to the oil that they used to produce the indoor coils to keep friction down. They're making their bends and, shooting a bullet down the pipe to expand the tubes in the coil. The manufacturers never got to test the rust inhibitor to make sure there wasn't a problem. So when they changed it without letting everybody know, that's where the problem came in. But I agree with you about adding a little more POE or certain chemicals just to dilute it.
Yes, it's a simple cure, very simple cure. I don't know what type of oil that they would use. I don't know what they use, like a cutting fluid. That is kind of a water-soluble product. Who knows? I'm sure they don't leave those residues in the coil.
I've been on several factory tours, and I've watched them when they get the copper in. I don't ever see it going through a bath, per se. I just see them pull it off the spool and go straight through their little bending process and then make the coil. Never saw it go through a bath, though.
The inside of copper tubing is sacred ground. It's usually packed with nitrogen or blown with nitrogen before they put the end caps on. I would really be leery that they would put any kind of chemical in there.
They're putting all kind of chemicals inside the compressor that we don't know about.
The rust inhibitor is necessary because you've got to protect all the different metals inside the compressor from oxidizing. And that's basically what rust is reacting with oxygen. And POE contains an oxygen molecule. If that POE ever breaks down, it will break down a little bit. You have free oxygen in there that is going to cause some corrosion, and the corrosion inhibitor is going to prevent that.
I was just telling you the story that we were told, and it kind of made sense to me. What do I know?
It's all about who wants to avoid liability and who can come up with the best explanation.
There you go.
The best storyteller wins.
Yes.
How about the dryers in the system? Because the temperature in that line at the time, these chemicals pass through the dryer, and when they hit the TXV, they get to the cold side of the TXV, and they precipitate out of the solution and just plug up the works. Is that how it works?
Yeah, well, the dryer isn't going to pick up the solid because it's still in the liquid phase. It's still dissolved in the oil. Where most solids fall out is going to be at that TXV. I saw this early on when the dyes came out. The dyes were okay if you used them on air conditioning systems, but if you ever used them on low temp, you'd get a residue that would form on the TXV outlets, and it was dye residue because the dyes, again, are solids, and they're dissolved in the oil. And of course, the colder that oil gets, the solids start coming out.
Why is it that they come out at that temperature? They just reach the temperature in which they're changing phase, and there's not enough pressure, or there's too much of the actual substance in there to remain a solution?
If you put too much salt in water, you could dissolve more salt in hot water than you can cold water. But if you took that solution and put it in the refrigerator, the salt could fall out because the solubility becomes less at colder temperatures.
Now, is this because there's just less space because of the density, because of the temperature?
No, because it's dissolved in oil, and as it cools down, it goes from a liquid back to a solid when it cools down. The products that he's talking about, its mass is different.
Anything that is solid at room temperature and you dissolve it in water or oil,
Exactly.
it's going to become less soluble the colder that fluid becomes. If you can imagine a bucket of ice water and then try to dissolve sugar in it, it takes a lot of stirring to get that sugar into solution.
Yeah, but once you warm it up,
it goes right into solution. Yeah.
it creates syrup.
I just had this image in my head of just like imagining air and how air has a certain specific volume depending on the temperature and humidity. And as it gets lower, there's less air space. So I didn't know if that forced some of the solution to precipitate out of it, is what I'm saying.
There's less molecular motion, so your molecules aren't as excited and they don't move as fast. As you lower the temperature, the molecules slow down.
Would y'all believe me if I said that's what I was imagining?
Yeah.
Yeah,
That's what I was imagining.
that's what's happening.
A lower kinetic energy or something like that.
Yeah, that's what's happening.
Man, that was a lot of science right there, guys. Maybe we should talk about sports for a while.
Maybe we should talk about the additives, like my favorite, Subco 88.
Yeah, you know, a long time ago, I looked at the MSDS on that, and that mainly kerosene and oil. So basically a solvent. I guess if you have some type of gunk buildup, which you shouldn't in any working refrigeration system, that will help redissolve any solids that have deposited anywhere in the system. Then again, the most likely spot for solids to appear would be at the expansion device. And if it gets too hot, you're going to see mineral oil decomposing and forming a shellac on your discharge valves. And I'm sure if you've ever popped a head off of a semi-hermetic air conditioning compressor, you can see some shellacking, some deposits, dark brown discoloration on discharge valves, or even in the discharge tubing, or a muffler, if there's a muffler in the system. That's from mainly the mineral oil decomposing. Mineral oil will decompose at just above 300 degrees.
So the POE will take more abuse than mineral oil.
Yeah, see, that's one of the advantages of using synthetic oils is their high tolerance for heat. Very, very stable at high temperatures.
Well, what about PVE? See, I don't know a lot about PVE. I just know it's newer on the market. And how come more people aren't using it?
They're not using it because I think it's about double the cost of POE.
It's all about that dollar, isn't it?
Yeah, and there's only one manufacturer of that particular molecule, and that manufacturer is in Japan. And it is a good oil, and it can tolerate all the moisture that you can feed it without breaking down. That is the one good feature of PVE. You don't have the oil breaking down when saturated with moisture.
Is that manufacturer PVE? Are they an air conditioning manufacturer as well?
No, I tried to get the distributorship on that back in the 90s because I read a lot of research papers about the PVE. And then when they told me what the price was, and I said, wow, I don't think I can compete in the market with this stuff. Trying to pioneer this stuff is better than POE oil. And plus, then you didn't have compressor manufacturers jumping on board.
Not at the cost, I wouldn't bet.
Matsushita, I believe that's the compressor used in most of the units coming from Japan. I believe they were the first ones to prove the PVEs. And that takes years of testing. So.
And the PVE's been around since the 90s, you said?
Oh, yeah, definitely.
Wow. So when the carriers were rolling out with Puron in them, there was already PVE in the works.
Yes, definitely.
Let's go back for a second. The POE, whenever it breaks down, would you describe what happens when it does break down?
POE is made from an acid and an alcohol. Those two molecules are kind of like reacted and fused together to give you your POE molecule. Water tends to reverse that reaction. Too much moisture, and with heat and with compression, that POE molecule now breaks back down into the acid and the alcohol from which they were made.
You've heard of green slime, right?
I've heard of it. I've never experienced it.
You've never experienced it. Well, I've experienced it. Not something you want to deal with on a daily basis. Let's put it like that. Because when they say green slime, it really is. It's horrible. And we don't see it anymore, I think, because what was happening was the POE, when it came in contact with moisture. Now, this is in the early 2000s, of course. When the POE was exposed to moisture, caused a bad acid. And what it was doing was eating the varnish off of the windings, causing that green slime stuff. I don't know what the manufacturers have changed to deal with that, but of course it doesn't happen anymore.
Well, as I mentioned in the beginning, there is now a new additive that they're using that blocks that reaction between moisture and the POE oil. You can't put an unlimited amount of moisture in that POE oil because it's just going to override the capability of that additive.
Assume you can't put as many additives as you want in there because it actually has to end up, performing like an oil when it's all said and done.
You don't want to affect the viscosity. You don't want the viscosity to drop out too bad at high temperatures. You don't want to inhibit the lubricity of it. If you drop the viscosity out, of course, you get thinner films of the bearing journals. They don't get lubricated as well. The science of oil and lubrication in engines is so sophisticated nowadays. When you go to buy a can of oil or a container of oil now at your auto parts dealer, that oil will come with all these different stamps of approval. You can see them, past this test, past that test, and they'll have little certifications, marks on their oil to show you all the tests that oil has gone through to be sold on the market and used in your car. And that's how they get approval from all the big auto manufacturers, is they get those certifications.
The other day, or not too long ago, one of the guys came in to buy some products, and he bought some Subco 88, some leak stop, some AC renew. I said, "What are you doing with all that stuff?" He said, "I make my own concoction, and I put this in every install." I said, "My God, you're wasting your money."
Hey, maybe we should take those one by one and see what John thinks of each one. We talked about Subco 88. Before we move on, John, is there any time when you would use Subco 88 for anything?
No, not at all. The customer I didn't like.
I know guys that for many years have used Subco 88, especially in heat pumps. We do have some reversing valves sticking, and they say it prevents it.
I can see where it would do something like that. But then again, you've got the kerosene in there, and that's a volatile. And that kerosene is a solvent that's not going to be very kind to your windings. I'd say get away with as little as possible if you're going to resort to that kind of stuff. But the only cure really is to replace the valve. Everyone's out there is looking for a quick fix. And that's why these additives are so popular nowadays. It's just slam it, slug it with something. Get you in, get you out.
I've got some videos on adding AC renew when we had that TXV problem. It really never worked for me, but I had to do it because they said, "We're not going to give you a valve until you do it." I was forced to do it. But at the end, I always replaced the valve because it just wouldn't work for me. Now, there are guys that said, "No, it always worked for me."
That's a good question. Let's move on to AC renew. What do you know about AC renew, and does it have any merit in any circumstance?
Well, first of all these additives, they used to be on the automotive side. And I was okay with all those additives as long as they stayed on the automotive side. And then they started filtering in to the HVAC side where, it's kind of sad. AC renew is ICE 32. If you were to go into your local auto parts store, ICE 32 is what it is. I know that because one of the inventors of the ICE 32 invited me to a seminar because he wanted me to start private labeling it from him. He was looking for more distributors for it. I said, no, thanks. And he says, well, he's this oil chemist with all this background. And he's worked for all these different companies and blah, blah, blah. And it was an ASHRAE seminar. And it was going to cost me like $900 to register for the ASHRAE show, not the ASHRAE show for the general public and contractors. This is the ASHRAE show just for the ASHRAE engineers. I didn't take them up on it, but that's what it is. I had a friend in Arizona, does automotive AC, and he sells a lot of automotive AC parts online. AC Kits, I think, is his website. He's in Phoenix. I went to his location because he was buying a lot of Nylog from us. He had a complete testing facility where he tested all these different additives, and he said he could never see any improvement out of any of them. The thing with automotive is they sell you on lower vent temperatures.
There's a company out there. I don't know if it's a good size YouTube channel, but they've made their way around some of the Facebook groups. Guys make fun of them all the time because they go in there when the system just starts up and they point their little infrared thermometer up at the vent. It's showing like 65 degrees and let it run 10 or 15 minutes. And then it shows, oh, look, we dropped your temperature 10 degrees just by adding this stuff.
Yeah, right. Overcharge it and you might get a little lower vent temperature too. I mean, Why not?
I know those people you're talking about. I don't remember their name, and I wouldn't say it if I did remember their name. But a lot of them say that same thing. AC Renew says that add this will lower the friction in your system. You'll get 2 more degrees, blah, 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 blah.
Generally, when I read the literature or the label on that stuff, I just say this is kind of a science that, if it was really true, is really worthy of a Nobel Prize. And I don't see anyone nominating them for Nobel Prize for.
I always say, if it really worked, why wouldn't the manufacturers put it in the system to begin with?
Exactly. With all the manufacturers out there, the manufacturers of equipment in the US, in Canada, Mexico, the hundreds of manufacturers in Asia, wouldn't they want a nice competitive advantage by saying that if you buy one of our systems, your compressor will last longer, they'll be more efficient, you'll never have a leak because we popped it with leak stop chemical.
Exactly.
So you never have to worry about leaks. But throughout the whole world, not one will take advantage of that marketing to promote their product in that way. That tells you a lot. And plus, all those systems, they have to be tested for efficiency, and they got to have pretty concrete evidence of the SEER rating. If they don't, they get knocked down.
I guess it might not be true.
No, Zach, it's not true.
And you'll never see any of those additives come with any certifications on them.
Wait a second, John. There is one manufacturer out there of a certain leak stop that say they are OEM approved.
Well, you have to look into that further.
I called them,
Yeah.
and you know what they said? We're not. I said, but your brochure says you are. Well, we're not.
You'll find very little test data published on any of that stuff. You're going to come up with an additive or something you're going to put in a system. You're going to go through what is known as a sealed tube test. And this is where they take different coupons of different metals, copper, aluminum, stainless, and steel, and they'll put them in a tube, and they'll put the oil in, they'll evacuate it, and then they'll inject refrigerant and the additive, and then they'll take that tube, seal it off, and put it in an oven at about 300 degrees. And they'll cook it 7 to 14 days. After 7 or 14 days, they will take a look at the metal, take a look at the oil for discoloration, and they'll look for corrosion on any of the metals. They'll look for discoloration in the oil. Of course, they'll test the oil for breakdown into acid. And they'll also take the refrigerant, analyze that to make sure that it hasn't broken down. And that's called the ASHRAE sealed tube test. And you'll never see that documentation accompanying just about any of the additives out there you see.
Doesn't look like we've seen any from anybody.
No. And that would be number one. I would always look for is, did it pass a sealed tube test? Can't find it anywhere. Call them up. Yeah, we got it here somewhere. It was done by an outside lab. But, we can't seem to find the paperwork right now, but give us your email and we'll send it to you when we find it.
I like that. The University of Bogota sent us something on it. I can't remember.
Yeah. And some of these people that make these additives, they actually will name a lab that did the testing, and they'll put all this test data that looks really good. The lab will say, yeah, it made the units work more efficiently. But if you call the labs, they'll hang up on you, or they'll say, well, we don't disclose our test results unless we have permission from the person that submitted the sample. They're not going to give you permission to go in and see their actual results. That's a little way of how they skate around a lot of avoidance of any credibility on their part. They can just publish any type of data they want, and then they can name the lab. Go to check on the lab. The lab's going to say, nope, we can't give you information.
How are guys in the field supposed to deal with that? They don't know what's good and what's not now.
The way we do it is we buy it off the shelf and we send it out. and have it tested.
I like that. I like that. Man, I'd like to
Oh,
see those
really?
test results.
Well, listen, this is my job. If it's a good product and it does what it says it does, well, I want it in my line. I want to be able to sell it, and I want to be able to put my name on it. But everything we've run across has always failed all the testing.
You'll actually get some samples of it and you'll send it to a lab.
Sure, I'll buy it right off the shelf. I've bought lots of products off the shelf and sent them out, had them analyzed. Know the components that are in there. You'll know whether or not they're onto something or if they're just pulling the wool over your eyes.
Man, I've often joked with Zack and say, Zack, we should start our own leak stop brand and just sell,
Sure.
and just sell POE in the can.
Well, you can do that, but I tell you what you can do. You can go to Dow Corning and buy that silicone compound that they're putting in the leak stop. You can buy it for 10 or 12 bucks a pound, and you just dilute it with a solvent, put it in a tube, and say, here you go, guys.
Really?
And
So we could take Subco 88 or kerosene, so we can go get some kerosene from the pump and some of that stuff from Dow and put it together, and we'll have a leak stop?
leak stop isn't going to have kerosene, but I'm talking about the ones that have the silicone, the ones that supposedly moisture cure.
Oh, no. We don't like that stuff.
Well, no, our leak stop has kerosene in it.
Really? What is that?
Me and Ralph's brand.
Yeah,
Oh,
ours is gonna be a lubricator
Well,
with
let me tell you.
leak stop in it.
You'll probably be successful with it. And I'll tell you why. Because I get emails, and ever since I came out with Nylock, they see the word sealant on the tube, and they think you're supposed to inject it in a system.
No way. Well, at least
Yeah.
yours is safe.
And I've had people call me. I've had people write me emails saying, ever since I put your sealant in these systems, I haven't had any leaks. And which, of course, is ridiculous, but I guess it's called the placebo effect. You will get a certain amount of people that will buy into it and want to believe in it.
John, can I stop you for a second?
Sure.
Did you just say that people call you and send you emails where they have injected Nylog into a system to stop a Freon leak?
Exactly, because they thought it said sealant on the bottle, gasket thread sealant. So they thought that they had to put it in the system would stop all the gaskets and threads from leaking.
Well, I hate to see what they're doing with pipe dope.
I just had a great picture of a guy with a big metal can of Thompson seal for their deck, just injecting it into their system. It's like my system's 100% Thompson's water seal.
But, also on our bottle, we say will not contaminate, harden or dry or clog or foul a system. So I guess that's where they don't read past the directions that you actually apply it to the outside of the threads.
Well, you're probably kicking yourself right now. October's here. You waited too long, and you didn't get 15% off on an iManifold by using the special promotional code we gave you last month. Well, there's good news out there, guys. You can still get your 15% off. The only difference is now, you had to use a special code FALLSPECIAL when you check out at iManifold.com. You can get your iManifold probes, iConnect, all sorts of goodies at 15% off throughout the entire month. So don't hesitate. Head on over to iManifold.com and pick you up some new stuff today and enjoy getting potentially hundreds of dollars off. Don't forget to tell them HVAC Shop Talk sent you.
Thank you for listening to HVAC Shop Talk. John Pastorello will be back later on this week to talk more about POE oil, the additives that we put into these systems, and why he says you never put anything into the system besides refrigerant and oil. A lot of guys would disagree with that, but John's got the brain to back it up. Also, don't forget about our YouTube channel, HVAC Shop Talk. We have our live stream giveaways, and now every Wednesday morning, there'll be a live stream swag giveaway then that evening we'll pick a winner. So it's going to be a lot of fun. We're going to have all of our sponsors pitch in some shirts, hats, and all that good stuff. So there's going to be a lot of great swag to win. As for our next big live giveaway on the weekends, not sure what that's going to be yet. But rest assured, by this weekend, you should have some sort of prize podcast to tune into, and we'll let you know what it's going to be and when it's going to be. Don't forget also that we're on the Blue Collar Roots Network. If you go to bluecollarroots.com, you can see a whole array of great podcasts you can listen to. There's no excuse for you to go through life or any day of your life without having a nice, fresh podcast to listen to. So go to bluecollarroots.com, and that's exactly what you'll have. As always, guys, we had a great time with you. I hope you come back again later in the week. Don't forget to listen to my other podcast, The Tradesman. Just interviewed Greg Fox. It was a very good interview. I enjoyed it very much. Greg's a great guy. We're going to bring him back over there as well. So until the next time we all get together in podcast world, you guys be safe, have a good week, and we'll see you on the next one.